Welcome to the SSI Orbit podcast, a forum that explores everything pertinent to digital trust. And I'm your host, Mathieu. For folks listening to this conversation, this is not meant to be an intro on decentralized identifiers. If anyone listening to this wants a little bit more of a foundational discussion on decentralized identifiers, or DIDs, which we'll refer to throughout this conversation, Markus and I did a podcast last year, so please go back to episode 52 if you feel like you want to just learn a bit more about DIDs overall before listening to this conversation. This conversation will go a little bit more deeper and talk about some subjects around DIDs, or what needs to happen for DIDs to be trusted, for DIDs to be adopted. And the framework I was hoping to use today, Markus, for this discussion was just kind of looking at a SWOT analysis around DIDs. So looking at some of its strengths, some of its weaknesses, some opportunities, and perhaps some threats. And hopefully we come up with some good conversation around that framing, which again will help with the overall intent of promoting the adoption of DIDs, because we're all aligned on tremendous benefits that they have. So along those lines, if we start our SWOT analysis with examining strengths, we talked a bit about this on the previous episode we did together, but maybe a good place to start is just on the topic of the identifier altogether, and perhaps comparing DIDs against other identifiers that exist today that we use, and talking a little bit about some of the strengths that decentralized identifiers have over other types of identifiers that we use in our daily lives.
Absolutely. So the most important strength, or the most important aspect of DIDs is of course, as the name suggests, so they are designed to be decentralized, meaning they can work and they can be created and used without a central authority and without intermediaries. There's this famous model or concept of Zuko's triangle, which has been a way of describing desirable properties of different types of identifiers. So there are three properties, right? Identifiers can be human meaningful, like domain names, for example. Identifiers can be decentralized, like let's say UUIDs, and identifiers can be secure, which means that if there is one identifier that cannot be controlled by someone else, so it's unique, right? And DIDs fulfill the decentralized property and the secure or globally unique property. They are not human meaningful, but this is one way of looking at the strengths of DIDs. Traditionally, we've also listed a few other properties that DIDs are designed to have. And again, there's the decentralized part, and DIDs, in addition to that, DIDs have also been designed to be persistent. So meaning that once you create a DID, it cannot be taken away from you, and it consistently identifies the same subject. And then also DIDs are designed to be cryptographically verifiable, and DIDs are designed to be resolvable, which means that given a DID, you can obtain metadata. Now, in practice, not all DIDs and not all DID methods actually fulfill all these properties in the same way. But conceptually, the fact that DIDs are designed and have the ability to have such properties, this is pretty special. So to my knowledge, there are, for example, not really any other identifier systems that are designed to be at the same time decentralized and persistent and resolvable. So these aspects together is a pretty strong and unique aspect of this.
Is the human readable aspect is maybe different among different implementations of the DID? Like for different DID methods, maybe some are more readable than others, but would you say that's a weakness that DIDs have, or perhaps it could even be viewed as a strength? I understand the secure and the centralized part, the persistent parts, but is human readability more of a, or lack thereof, more of a strength or more of a weakness of DIDs?
Well, it could be both a strength or a weakness depending how you look at it, but it's what it really is, and what also the sucrose triangle, what that model says is that there are trade-offs, right? So if you have DIDs that are more human readable or human meaningful, like the DID web method, for example, then those are then typically less decentralized, for example. So that's the trade-off that you have between the different properties. And during the evolution and development of DIDs, there have been many debates about this, right? So like I said, DIDs have been designed to have these properties, but they're not always really accomplishing them to the same degree.
There's a whole conversation around different types of verifiable identifiers or self-asserting identifiers from different spaces. Could you contrast DIDs to these other types of verifiable identifiers and perhaps talk about some of the benefits again that a DID has versus other types of verifiable identifiers? And for folks listening, like an email address and a phone number are identifiers, but perhaps not verifiable, not cryptographically verifiable, but there are other types of cryptographically verifiable identifiers that aren't DIDs. And do DIDs have benefits over these? Maybe you could shed some light onto that.
Yeah, there are definitely other types of identifiers that are cryptographically verifiable. For example, the term cryptonym has been used sometimes. You could also consider just a fingerprint of a public key to be a verifiable identifier, and also a number of other efforts like AIDs, autonomous identifiers, as they're being used by the carry community, for example, that are also cryptographically verifiable. To contrast some of those to DIDs, I would say there's a lot of overlap and a lot of similarity. Of course, one of the things that DIDs are also trying to offer is a standardized identifier format, a standardized discovery metadata format, the DID document, and the extensible architecture provided by DID methods, right? So this is also a key element of DIDs, that there's not just one way or one type of DIDs, but that DIDs themselves also constitute an abstraction layer, and in many cases, if you look at other non-DID identifiers, then in many cases it's also possible to design a DID method around them, and then also consider those other non-DID identifiers a type of DID again by just defining a method that makes them a DID.
What would be an example of that?
Carry and carry AIDs, right? So carry has this concept of autonomous identifiers, which in many ways is a very radical type of cryptographically verifiable identifier that does not make any trade-offs, where trust and decentralization is really based on math and cryptography itself, and there's really no other system like blockchains or other decentralized networks that are required for that. So that's why carry and AIDs are getting quite a bit of attention. But there's also a DID carry method, right? So this type of identifier can again just be considered and treated and mapped to a DID method, and therefore also considered just a new DID method with its own properties.
There's also, just closing the conversation on strengths of DIDs, that there's obviously I think the phone number has become the most abused identifier, and email address is maybe second. I don't know if they flipped or what, but I think just the privacy benefit of DIDs or being able to use different DIDs for different types of interactions or the even the non-discoverability of DIDs perhaps are big benefits that they have to reduce a lot of the abuse and fraud that just happens in our everyday lives today.
Maybe one thing to mention that sometimes it could also be useful to use DIDs and to define DID methods for other types of identifiers that could also be used in a non-DID way, but we're using DIDs and defining a DID method just has advantages, again, because of the standardized identifier format and the standardized discovery format. And here I'm thinking again about DID web, right? So domain names are not new, and web addresses are not new, and HTTP URLs have been around for a long time. And there are many applications like verifiable credentials and other things where you could just use HTTP URLs with domain names, but still there's been the development around DID web to identify a DID method around these existing identifiers, simply because it's easier to have the standard identifier format and the standard document that describes the metadata about a subject, right? So in terms of the properties of the identifier and the infrastructure that it is based on, there's not really a difference between HTTP or HTTPS URLs and DID web identifiers, but still people are using the DID format simply because of the standardization of the model around.
If we move towards weaknesses, and as I'm thinking through these, I think a lot of these are nuanced as well. Like a lot of when we're looking at strengths, you could look at things different ways, and same things with the weaknesses as well. But maybe a framing for this one. We've had conversations about this before, Markus, about like how do I trust a DID? It's one thing that a DID is created and someone's presenting a DID to me, and then they're making a claim or they're asking for something, but how do I trust that DID? What do I need to depend on to trust that DID? So it might be useful to dive a little bit into that question from just a technical dependency standpoint, but also there's like a whole governance standpoint there too. So how do I trust a DID?
Yeah, how to trust a DID? That's a really interesting question, and one that's probably a bit more difficult to answer than with other types of identifiers. Again, due to the nature of the DID model and DID architecture, because of two reasons really, right? So one reason that makes the difficult question how to trust the DID is the variety of DID methods, right? You can only trust the DID to the extent that you can trust the DID method, and there's a great variety of DID methods, and depending on the DID method that is being used, there are different parties or concepts or technologies that you implicitly have to trust, right? If you use DID web, then you have to trust the domain name system and the web server and the HTTP protocol and so on. If you use blockchain-based DID method, then you have to trust that blockchain and so on. So there's not really one universal approach to how you can trust DIDs, because there's so many different ways how DIDs can work, and that's the essential difference to things like domain names and the DNS system, because there you have one protocol, right? DNS resolution, one way how domain names get created, one way how they can be resolved, and you have a number of building blocks like DNSSEC and so on that are relatively easy to describe, and but with DIDs you don't have that, right? Because you have all these different DID methods. So that's one reason why the question is not so easy to answer. And the other reason is also that then DNS resolvers, so those are then the software or hardware components that that look up a DID and retrieve the associated metadata, the associated DID document. These DID resolvers, they can also come in different forms. Right? So DID resolver can be a remote service, and then you have all the trust-related questions that come with that. How can you trust a remote service? Who operates that? How can you trust that it returns the correct response? And so on. But DID resolvers can also be local processes, right? So that's the second dimension of trust in DIDs, if you want, right? So I feel like there is these two dimensions: trust in the DID method and the mechanisms it defines, and then trust in the DID resolver in the form that it comes with, or the way how it is deployed and used.
How do you build trust around a DID method? Does it inherently need to have some linkage to governance or some external human trust thing to trust a DID, or is it really just trusting the technical integrity of it altogether? And I think again in the nuanced discussion, having tons of DID methods to choose from is is a good thing for offering flexibility, but then is maybe a lesser of a good thing to build trust towards DID methods altogether, because it's a little bit more difficult to come up with one process for this. And it almost makes me think too of, so you mentioned the DNS is one way to resolve, but the difference in these identity, as Kim Cameron would say, like meta systems, is you're not just going to have one namespace, one way of doing everything. It just won't work on the internet. So if you're going to have a plurality of options, how do you build trust in any singular DID method? Is it a governance question, or could it just be done technically? Does it need to be done in the DID core spec itself? Like at what layer do you need to create improvements?
Well, you can, of course, try to build individual DID methods in a way that maximizes or offers trust, right? That's one reason maybe why there are so many different DID methods, because the different answers or different understandings of how you can build trust within a DID method, right? And that is often a political or ideological question, where some people would say that DID methods that are using more or less decentralized blockchains can be trusted, and DID methods that are based on hierarchical systems like DNS cannot be trusted. And there will be other people again who will say that only DID methods that rely on only cryptography and nothing else, like DID key or DID carry, only those can be trusted. So that there's definitely an element that is DID method specific, right? And there's also, of course, this whole discussion in the blockchain or distributed ledger community around the permissioned or permissionless ledgers. Do you have a public permissionless network where anyone can run a node, and you have a consensus mechanism based on different assumptions, or do you have a more permissioned system where there's an authority that governs who operates components within the DID method? So there's this entire class of questions of how to build trust within a DID method.
If I could just add, so it's obviously not a straightforward answer, as I'm understanding. It's more like different DID methods will make you have to rely on different other systems or different trust infrastructures. Like there's reliance on other trust systems or dependencies on other trust systems for any of these methods, would you not say? And that's just kind of like based on your context, where you're comfortable making these I wouldn't say concessions, but accepting other trust models?
Well, one aspect of this, or one consideration that goes beyond the different DID methods, or one way of then building trust potentially across different DID methods. So to try to build trust on a level above that could be done potentially by linking DIDs of any DID method to some other existing trust infrastructure or trust registries or sources of trust that already exist somewhere, right? And by that I mean, for example, the idea of linking DIDs to X509 certificates. So there's been a lot of work on that and a lot of different proposals on how that can be done. And then in that case, the theory is that if you have a way of linking DIDs to X509 certificates in a reliable way, then you may not have to trust the DID method itself, because there would be a cryptographic link between the DID and the other existing infrastructure that can be verified. Another example is trying to link DIDs to the DNS system, including an infrastructure based on DNSSEC, right? So in that case, the idea is again that even if DIDs by themselves, or the DID method does not provide the level of trust that you need, and by linking that to a DNS and DNSSEC based infrastructure, it should be possible to verify such links and to verify the correctness of the data associated with the DID in a way that's DID method independent, right? And a third example that comes to mind again has to do with the carry community, the carry ecosystem, which who has done a lot of work on trying to establish trust in a relatively radical way that only relies on cryptography. And there have been also interesting initiatives to link that trust infrastructure, or that very deep cryptographic trust, to other DID methods, or to DID methods which by themselves alone may not have sufficient trust, right? And here I'm thinking about the DID Web S method, which is like DID Web, but it doesn't actually trust the DNS and the web infrastructure. It only uses those for discovery, but in order to trust that DID method, it again uses the carry-based cryptographic model as a basis. So these are three examples, right? X509 certificates, DNSSEC, and carry, where the concept is that in a DID method independent way, you can attach trust to DIDs.
It's almost like a concept of multi-factor authentication that you're describing then, because you're still in control of the identifier of the DID, but you could, I guess, show that you're the controller of different identifiers, or you're able to show that it's the same signature across a DID doc or a DID in other locations. Just like I think for authentication online today, there's been a big shift in the past few years to multi-factor authentication for a lot of relying parties. Would that be the idea then, is it a multi-factor authentication for a DID? Is that a good framing?
Yeah, I think so. I think it's a valid comparison, or valid way of describing it, because you would resolve the DID, and hopefully do that with a DID method and with a DID resolver that that you can trust. And in addition to that, you have an additional way of verifying that you get the correct result by verifying a link to an X509 certificate or to a DNSSEC infrastructure or to a carry key based key infrastructure. So yeah, I think it's a good way of putting it. And all of what we've talked so far is about the technical trust, right? It's about how you can ensure that you get the correct deed document, the correct metadata about the deed. So so far, none of that has really been about human trust, right? How do you know who is behind that deed? So that's an entirely separate question in my mind.
Although by leveraging other trust anchors like X509 or DNSSEC signed DNS records or carry, you could be leveraging other governance mechanisms behind these things. But you're right, like it still becomes difficult to know who the actual identity or so we've kind of described like discovery happenings, resolution happening, but then the whole verify part is maybe not there yet. And just to come back, so I was trying to move through the SWOT analysis type of thing, and we're still on weaknesses. Although as I'm going through this with you, Markus, it's just everything's so blended. So let's keep moving. But while we're on the topic of DID documents, I do want to get to resolution as well because we're talking about perhaps relying on other systems or other components. So there is a reliance on the DID methods, the DID documents. There's a reliance on the resolution part of things. But if I'm relying on a DID document, one of the things that DID documents, and again, it varies across DID methods, but it allows you to put certain information in there, is putting governance or more human trust inputs into a DID document possible, smart to do, or should these things just remain technical and help achieve, I guess, discovery and resolution and not verify? So yeah, are you able to mix the human trust and governance into the technical side of things when it comes to a DID doc, or should these things remain separate?
I think both is possible, and I would say since DIDs were first invented and since people started to work on DIDs years ago, the understanding of this question has also changed a few times. So the most common answer today that you would get is that you should, in many cases, not mix that, right? And you should in the DID document only have the minimum amount of information in order to enable trustable interaction, right? So service endpoints and public keys and nothing else. And the usual justification explanation for that has to do with privacy and correlation and regulations like the GDPR in Europe. So you should not have personal data in your DID document. This also has to do with the fact that historically many of the first few DID methods were based on blockchains where you have this immutable and fully globally visible data structure, and then it makes a lot of sense to not put any kind of personal data into the DID document if that becomes immutable and visible to anyone. So this is the most common answer, right? That you just should have the minimum amount of information in the DID document, and then if you want to exchange any kind of human data or personal data, you should do that in a different way with DIDCOM or OpenID or wallets or things like that. But it's also interesting to know that originally, again, in the first few specification drafts in the early days of DIDs, there has been a concept that a DID document itself could contain verifiable credentials, right? So that was done a bit the opposite idea, where for a short while at least, there was this approach where you would discover in the date document both technical data and also potentially claims about the subject. And my personal opinion is that it can still make sense, or maybe for use cases like organizational identity, right, where you have less of privacy concerns, but to include claims, to include more than just technical metadata in the date document, I think can make sense, and in some cases, if it's carefully considered. The date document data model technically certainly allows that. Not all did methods supported in the same way, right? So there are some did methods that are a bit restrictive and what you can actually put into the date document. But maybe also to add that is that recently in DIF, in the Decentralized Identity Foundation, there's been a new work item which specifies how you can use a date document service endpoint to link directly to a verifiable presentation, which would then contain credentials about a subject. So that's maybe a little bit of a middle ground, right, where you don't have human trust related information in the document itself, but you do have a link to a verifiable presentation. And here again, it's recommended to only use that for a legal entity and not for people.
Yeah, it's interesting. I do agree if you're going to stick claims inside of a DID document, claims about organizations that are sharing public information anyways is less of a risk than putting claims inside of the document for an individual. Let's say you brought up privacy and correlation and data privacy laws as risks there. It kind of blurs the line between the identifiers and claims, I guess, because like verifiable credentials are claims. You could put a claim in a DID doc. You could put a claim in a trust list. At the same time, putting a claim in a DID document could help you trust a DID more than if the claim was not in there, and it's maybe a lower lift to resolve a DID and verify a claim in a DID doc than it would be to have the infrastructure needed to verify a verifiable credential. I just don't know where the line is, if there is a line. But it's just like, if we're talking about, yeah, I want to have like signed claims to build trust. How far do you go in a DID, and does it start to impact other processes like resolution and performance and stuff like that? The resolution must get complicated at that point if you're going to start adding stuff in there and you need to verify claims.
It's an interesting question. Well, if we let's say if we did that, if we put claims or verifiable and credentials into a DID document, or even just a link to that from the DID document, would it be in scope of the DID resolution process to try to verify that, right? So you could argue that it's not part of the DID resolution process, because DID resolution just gives you the DID document, and then some other layer in the stack is responsible for verifying any other information in there. However, DIDs and DID resolution process is also extensible, right? There are resolution options, there are DID parameters. There's one DID parameter, for example, called HL, right? Hash link, where you could add to the DID, you can add a hash of the expected DID document, and then the resolver could verify if the DID document corresponds to that hash that you have provided to the resolver as a parameter. And I'm imagining theoretically you could define an additional parameter for the DID resolution process that tells a resolver to automatically verify all the credentials that it finds DID document, and there can be DID parameters or DID resolution options to automatically verify a link between a DID and X509 certificate or a DNS sec based domain name or something like that, right? So you could build additional verification logic into a resolver itself and just define some extension features to enable that.
The second piece of how do I trust the DID? So you started by talking about the DID document, and then you touched on the resolver again. So you're kind of delegating a process to the resolver, and so I'm sure you don't want to pick up just a random resolver on the internet, because if you're relying on what it's going to tell you, it may be not telling you the right information if there's the fraudulent resolver. And there's different types of resolvers as well, right? Like in a lot of implementations, you'll have a resolver embedded directly into the agent. Some will use third-party resolution services. Like I know you offer some at Danube Tech. And if you're an enterprise as well, like you would imagine a lot of enterprises want to have a resolver with them, like on-prem, or at least have control of this. So when I talk about how do I trust a DID, the resolver plays a big part in this as well. And should there be any efforts to standardize the resolution process? We just talked about maybe resolver is extensible and it could verify claims as well, but does it make sense to have more standardization in the resolution space?
Well, in my opinion, absolutely, right? So we have the DID core specification, which is a W3C standard, which defines just the interfaces for DID resolution, right? So it defines basically what are the inputs and what are the outputs in an abstract way for DID resolution, but it doesn't define, just doesn't say much about how that works and what types of resolvers there are and how you interact with them. In the W3C credentials community group, we've been working for some years on filling those gaps and to add more considerations and more language on how DID resolution works, including on how, for example, you could invoke a DID resolver over an HTTP API as one way of interacting with a resolver. And at the moment, there's a process in W3C, of course, to try and establish a new DID working group. And the plan is for that new DID working group to really put a strong focus on standardizing DID resolution to try and answer many of these questions that we're also discussing here, right? Like how do you actually interact with a resolver, and how can it be, what kind of architectures there could be. Like you said, sometimes DID resolution is just a local process, right? We definitely don't want to give the impression that DID resolution should always rely on some third-party service that would contradict the spirit of DIDs, right? But the point is again that yeah, DID resolution can be based on different architectures, and it will definitely help to have a working group to standardize that a bit better.
If we talk about opportunities, which we've kind of been covering some a little bit here in the last part of the discussion, opportunities for DIDs to continue being easier to use, easy to deploy, and more valuable. What are some other opportunities that maybe the community could work on? One off the top of my mind is just like we're talking a lot about the discoverability, resolvability, and verifiability, but or being able to verify, but did method discovery um, a challenge or an opportunity that could be worked on as well?
Since there are many different DID methods and not everybody implements the same DID methods, how do you know which ones are supported? How do you discover the DID methods that are supported by a resolver or within a certain industry or within a certain use case? I think it's a topic that has been discussed a lot now in the process of creating a charter for the new DID working group, right? One of the controversial topics around DIDs has always been how interoperable DIDs are, right? And while one part of the community argues that DIDs themselves are a technology that enable interoperability because they provide this abstraction layer on top of different identifier systems. Some other communities have argued that because there is no single mandatory and authoritative list of DID methods that have to be supported, because it's basically up to individual communities and use cases and ecosystems. There's no guaranteed interoperability between DIDs, right? Because maybe in my resolver and in my use case, I implement DID web and DID key, but in your jurisdiction and in your wallet project, maybe you implement DID ION and DID JWK, and then how do you achieve practical interoperability? And the realization is that maybe that's a trade-off again, right? If you want full global interoperability of all DIDs, then that would in turn reduce the level of decentralization, because you would be forcing everybody to use DIDs and DID methods in a certain way. But there have been a lot of interesting suggestions, right? For example, a DID resolver could definitely describe and advertise which DID methods it supports. Also in DIF and the Decentralized Identity Foundation, there's another very small work item that all it does is it defines a little JSON-based data format that you can use to express what DID methods you support. Right, so that's something that a resolver could express. Another idea that has been proposed is that if a resolver does not know how to resolve certain DID methods, it could provide a response to a client with a potential list of known other resolvers that might be able to resolve a certain DID method. So you could imagine some kind of redirection or proxying architecture where the DID resolvers work together, starting ideally with a local resolver, right? So you could use a local resolver for those DID methods that you can easily resolve locally, but you may have a list of DID resolvers that support other methods, and there have even been some proposals to create a completely decentralized network of DID resolvers that somehow communicate or advertise how capabilities of what DIDs and can be resolved. So that there's definitely some interesting room for innovations.
Does a particular DID, I guess, because it's a bit of a uneven comparison if we're talking about different DID methods, because as we've talked about, they have their different dependencies and considerations. But if you just take like a particular DID method, doesn't matter what it is, but just talking about the same one, if it's implemented across different credential exchange protocols, for example, like if like a DIDCOM based protocol or an OpenID protocol or anything else, does it have the same value across different protocols? if this question makes sense, because like if you think about like a DIDCOM protocol, you need a DID to be able to work with it versus some other protocols like OpenID don't necessarily seem to be advocating much for DIDs, although they could be incorporated in there, and we could get more into that in a few minutes. But does the same DID method or based on the same trust model or whatever have the same value across different protocol implementations?
So it's again an interesting question. I think in theory that should be decoupled, right? So a protocol or an application should I think not have in theory, right? Not have a preference of what DID method you want to use. So conceptually, these should be in entirely different layers, right? For the DID methods, you have a choice of what properties of the individual DID methods appeal to you. We talked about that, right? The trade-offs around decentralization and what kind of trust comes with which DID method. So, and that is the basis for how you set up and manage and use your identifier, and then the services and applications that are using that identifier that can be discovered from the identifier in theory should be decoupled, right? But maybe it's not always entirely like that. For example, not all DID methods provide the same features for the DID documents, right? There are some DID methods that don't support service endpoints. There are some DID methods where the DID documents cannot be updated. There are DID methods where you can have any arbitrary extensions in the DID documents, and there are DID methods where you cannot have that. So if you have some application or protocol that requires some of these features, then of course you cannot use every DID method in an equal way. But
regardless of the preference of DID method, like DIDCOM suggests that you need to use a DID or whatever to be able to participate over communication over DID. That kind of is in the name, versus something like OpenID does not specify that you need to use that specific identifier type. So does the value that a DID brings to like a DIDCOM exchange or interaction, does it bring a similar value, a DID altogether, to like an OpenID type of interaction? And where I'm trying to go with this too is, I guess this is more, I was looking to finish the conversation talking about threats, but there are existing large companies that are in the business of assigning identifiers to people. And they don't seem to be advocating very much for decentralized identifiers because they're in the business of assigning identifiers and they monetize that. So I wonder at times if DIDs are not suggested in certain environments, and maybe gets too political, but because of these reasons, because it's threatening to incumbents, or if it just doesn't have the same value. Like implementing a DID for OpenID credential exchanges doesn't have the same value as it does for other credential exchange protocols, if that makes sense.
it's definitely a political question about interest and existing business models of actors or members of communities that promote certain protocols and technologies. In theory, I would argue that protocols like OpenID could definitely profit from the features and properties of DIDs, like the persistent identifiers, the cryptographic verifiability, the ability to update the DID document, right? The ability to update your public keys without having to change the identifier is definitely something that would be valuable also in a stack that uses OpenID or one of the profiles of OpenID Connect, OpenID for VCI. But there's also an aspect, I think, around the assumptions and the values that are just inherent to certain protocols, right? So going beyond the political questions around who is working on what and who has what kind of products on the market, I think it's also interesting to realize that the technologies are not neutral, right? So the technologies have always have some inherent values and assumptions built in. The classical example here and the interesting comparison is again DITCOM and OpenID. And some people would argue that DITCOM is inherently designed to be egalitarian and based on a peer-to-peer concept, right? You don't really have clients and servers in DITCOM. You just have peers, and both sides of a connection are identified with DITs, and they are both equal, right? And so that feels like it naturally aligns also with the original intentions of DITs, whereas in OpenID you don't really have this kind of symmetry, right? In the OpenID community, yes, you have OpenID support for verifiable credentials and for issuers and verifiers and wallets where you control your credentials and so on. But still in any OpenID interaction, you still have I would argue, a certain asymmetry where one party is the client and the other party is the protected resource, and you have the OpenID provider, which can be a self-issued OpenID provider, yes, but it's still always a request and a response, and the two sides of the OpenID interactions are not really considered symmetrical as it is in DITCOM, and therefore maybe one protocol aligns more naturally with DITs than the other one.
In the OpenID for verifiable credentials, as it says in the name, for verifiable credentials, so it's basically using an existing model that is used today, but just adapting it for verifiable credentials to be used as tokens type of thing. But then like the focus is often, I find, too much on verifiable credentials and not enough on identifiers and the trust models that come with it. And I feel the more time that you spend thinking about trust, it's just like the credentials are cool. There's awesome use cases for it, but it's kind of a secondary conversation. But at least if you're looking at credential exchange protocols, OpenID is developed for a specific purpose and using credentials for that. But like there's a lot more thinking and a lot more value that could be created out of decentralized identifiers beyond exchanging a credential to access a system.
Oh yeah, I completely agree with that. I find it sometimes a little bit sad that it's great to have so much interest and so much energy and funding and political support for things like digital wallets and so much development in OpenID for VC issuance and for verifiable presentations, and there are a lot of companies and a lot of use cases around that. And I think that's definitely a good thing, right? Because we are getting towards a point where digital identity becomes something that's more under the individual's control, and credentials only get shared with your consent and so on. So all of that is really good, but it still feels like there's so much more out there that can be done, right? Like decentralized social networks, the decentralized instant messaging, or really any kind of transaction or interaction that can be built over a system that's based on DIDs and decentralized identifiers. I mean, recently DIF had a hackathon, right, with a lot of submissions, a lot of interesting projects, and it was really great to see how much creativity and how many ideas people have been working on, including using things like decentralized web nodes or DITCOM agents. So we could talk for a long time about that, but just to agree that yes, data is definitely the basis for potentially much more than just verifiable credential exchange.
Yeah, and like we were talking about earlier, if if you start incorporating claims into DIDs, then it kind of potentially changes the paradigm a bit more. And again, the more like we've been thinking about this stuff, the more you realize other useful features. Like just this is another opportunity, maybe just like the life cycle of a DID document for an enterprise or for anyone is actually quite useful as well. And you start finding that a lot of these agent technologies and stuff that have been very much focused on credential exchange, like they don't even support like the doc update features and stuff like that, which are like just in any real enterprise use case that they want to benefit from this. It's like this is a this is a must-have, another opportunity to just increase the usability and the value of DIDs.
And so to me, what has always been most interesting about DIDs that it's really not so much about the technical questions or what technical features to achieve, but inspired by the self-sovereign identity ideological concepts. So to me, DIDs have always been a quest basically to find out and to describe how really to establish a link between physical identity and digital identity, right? Like what is the bridge between that? What is the act through which a digital identity is actually created that refers to a identity in real life? And if you think about it that way, then DIDs and DID resolution feel like a very close mechanism, or very appropriate mechanism for bootstrapping a digital identity that is as close as possible as identity really works in the physical world, right? Identity that is independent of external third parties, external authorities, or something that's yours and that cannot be taken away from you, right? So that at least for me has been the original spirit of DIDs, and should keep that in mind.
As we move forward and try to build more ways into creating trust around DIDs and utility for DIDs and adoption of DIDs, you named a few areas where there's different work happening, but maybe for the listeners, could you maybe just talk about some of the working groups or current activities going on that may be of interest for people to join and contribute towards?
Yes, there's in W3C there's the credentials community group, which is always a good place to discuss any kind of topics that have to do with DIDs or verifiable credentials or related things. And as I mentioned, also in W3C, there's right now an ongoing process to establish a new DID working group. So that's once that is established, it will definitely be a great thing to follow and be involved in. And in DIF, of course, we have our identifiers and discovery working group, where we often discuss topics related to DIDs. We often hear about ideas for new DID methods, or also things, applications, and protocols that are being built on top of DIDs. Yeah, there's also Trust over IP Foundation, of course, where some work is happening on bridging DIDs and carry. So I'll recommend that as well.
Thanks for listening. I hope you enjoyed these conversations as much as I do. If you haven't already, make sure you subscribe to this podcast on the platform of your choice to make sure you're notified of new episodes that may be of interest to you. If you're looking to connect, feel free to reach out directly to me on LinkedIn or Twitter. Catch you all later.